Hello, my lovely viewers and my dear students. Welcome back to my channel, Mathematics Made Easy. And today I have a news alert for you. We have now officially started our Instagram account. So this is the account. You can scan the QR code to follow me. The account name is Teacher Miss Ruchika, and I will put the link in the description box so that you can click on it and follow me on Instagram. Another good news, a news alert is that we are now also on our official Facebook business page. So I'll again put the link in the description box. Make sure you like to the link and you connect me on my Facebook business page. All the updates relating to our channel Mathematics Made Easy will be uploaded on this page. So I recommend you to please like and connect with me on the business page as well. Okay, so let me tell you about today's video. Today's video is going to be part 8 of the series of probability and measurement that we started for grade 9 and 10 students. And in the session today, in this video, you are going to be looking at what is the difference between independent and dependent events. Very, very important session. So let's get started. Okay, so before we get in further with the session, let me give you the learning objectives. In the session today, you will understand the difference between independent and dependent events, and you will also be able to identify and distinguish between these two kind of events. We are going to be covering this topic in great detail. Today's session is part 1, where you are going to follow with these learning objectives, and the next video is going to be part 2, where you will see in detail how and what kind of questions can you expect from this topic. So all my grade 9 and 10 students, this is a must watch video for you, and many questions do come in your exam from this topic. Okay, so let's start this topic with an example. As you can see, there is a jar here. Commonly, this kind of an example is called a probability jar example. And let's look at the number of marbles or the balls which are there inside. So I'm sure you all can see there are 3 different colors that I've taken here. The red balls, the blue balls, and the yellow balls. Now, sometimes it also comes as marbles. So it may be red, blue, or yellow marble. Whatever is the context of the question, the method to solve such a question would be very, very similar. So I want you to now focus and let's count the different types of colors of marbles or balls present here. So 1, 2, 3, 4, 5, and 6. I can see 6 red. So I'm denoting with this alphabet. Then I'll change my color and take blue. So 1, 2, 3, 4. There are 4 blue marbles or 4 blue balls. And finally, let's take the yellow one. So 1 and 2. So there are 2 yellow. I've taken the same colors here just to make you understand easy. So let's now total this that we know the total number of marbles or the total number of balls. So you can add 6 plus 4 plus 2. So these are 12 marbles. Okay, so that's the total. Now there are 2 kinds of questions that can be asked in your exam. This is a pretty important slide. I'm just explaining you the concept and the difference. What happens when these marbles are picked up from this jar or these balls are taken out from the jar one by one, and there can be 2 cases. So case 1 or type 1 is when the balls or the marbles are replaced. Okay, so if you take one out and then you put it back after you note down the color, that is what is with replacement. You're putting that marble or you're putting that ball back into the jar. Okay, and case 2, the kind of question that can come in your exam is without replacement. And in this category, what happens is in the question, it will be mentioned that once you take a ball or a marble out of this probability jar, it would not be put back or it will not be replaced. So what is the basic difference and what should be our approach when we are trying to solve these kind of questions? Let's understand. So the case when it is with replacement, for example, I need to find, like, for example, let me take a general case for both of them where we are taking out, say, 2 balls, okay, one after the other. And when it is with the replacement, we want to just see what is the probability that these both balls which are coming out are, for example, red. Okay, and the same case is for the case 2 without replacement. It's just that the balls are not put back. So again, you need to find the probability if your 2 balls are taken out, and what is the probability that those 2 balls are going to be red, one after the other. Okay, so let's come here back to the jar and see how can we find the probability. Now, I hope you all can recall that the probability of any event E, now we are talking here about the theoretical probability, because we are looking into this jar and we have to do the formula for probability. We have to use this formula for probability when we are solving the question. So the probability of an event here is given by the favorable outcomes to that event, if the event that we are considering, and we have to divide it by the total number of outcomes. So I'm just okay. So this is the formula that we'll be using for both the cases. So let's come to case 1. Now the first ball that should be drawn is red. So how many red balls are there? Let's see. There are 6 red balls out of a total of 12 balls. You can also count and confirm. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So yes, there are 12 balls. So the probability for red is going to be in the first draw, because we are drawing 2 balls one after the other. So in the first draw it will be 6 divided by 12. You can simplify. This will come out to be 1 by 2 or 50%. Now we need the second ball now also with replacement. So we've taken that red ball out and we are putting it back again. So for the second time that we are doing, maybe we can write this as R1, the first one, and R2 as the second one. So in that case also, because the ball is going back, so after you, for the second draw also, you will have the favorable outcomes as 6, right? So 6, and the total is also unchanged because you're replacing the ball back. So 1 by 2. So these are the individual probabilities. And if the question is asking you, what is the probability that the 2 balls drawn one after the other is red? Then in that case, your final answer would be, you just take the two probabilities and multiply. So it will be probability R1 multiplied with probability R2, which is 1 by 2 multiplied with 1 by 2, or 1 by 4. That is your final answer for case 1. Now let's see what changes when we move to without replacement. I'm going to use a different color here. And for the first case, when the first ball is drawn red, the probability will be definitely the same because there are only 6 out of 12 red balls. So this is not going to change. 1 by 2 is the same thing. Let's see what will change. Now what is happening when we are doing the draw second time? And in the second draw also we are getting a red. Now, because this case is without replacement, students, you need to understand that once a red ball is drawn out in the first draw, it is not put back into the jar. That means the total number of balls are also reduced. Now it is not 12 anymore, it is 11, because one red has already been taken out, and then the total number of red balls will also reduce. It will no longer be 6 because one has already been taken out, so it will be 5 red. In this case, the second draw, the probability of the second draw and the ball coming red has changed. So this is the case without replacement. And again, for the final answer, if you need to give in what is the final answer, or what is the probability that the two balls drawn would be red without replacement, then your answer would be again the product of these two, but this time it will change. 1 by 2 multiplied with 5 over 11. So final thing, 5 over 22. So this is a very, very important concept that we have begin our session today with. And I'm sure looking at this example, you have clearly understood the difference between the two cases with replacement and without replacement when we are solving a question on probability jar. And this example would be really, really helpful for you all to understand the concept of the difference of dependent and independent events. So let's get further and look at their definitions and formulas. Okay, so in the last slide where we saw the example of the probability jar and we saw the two cases of with replacement, without replacement, that lands us to the concept of independent events. So let's understand what are independent events. So when there are two or more events and the outcome of one event is not affecting the outcome of the other event, then such events are called independent events in the context of probability. Let me give you a very simple example. For example, you are tossing a coin, that's your first event, and you're also simultaneously rolling a number cube, that's your second event. Now, in these two events, as you see, in one you're tossing the coin, in the other you are rolling a die and rolling a number cube. So both are different events, and definitely because they don't have any common relationship with each other, so the probability of getting a head or a tail in the first event of tossing a coin, or the probability of getting any number on the number cube, they are not related to each other. So the probability of one is not affecting the probability of other. Therefore, this can be a wonderful example of an independent event. To just sum it up, independent events are the events A and B. In general, we are taking capital A and capital B to denote these two events, where A occurring does not affect the probability of B occurring. Okay, and when you're trying to find a common probability, as you saw in the previous slide, then we can say for independent events, we just need to multiply the probability of the two independent events that we are considering. So let's take an example where we need to identify independent and dependent events. Now here you can see that there are two dice, two number cubes, and we need to determine whether the event is independent or dependent. Also, you need to give a reason. So the event is being defined, event A, as the die is rolled, and B event is the second dice roll. So there are two dice here. For event A, you are rolling the first die. For event B, you are rolling the second die. Now, definitely these are two different dice. So the probability of getting any number on the first die, that is A event, and the probability of getting any number on the second die, they're not related to each other. They are two different dice. So these events have to be independent. That's an example. And the reason that you can give here why they are independent is that because the first roll or the number coming in the first die, that is your event A, in no way changes the probability of the second roll or the second die. So these two events A and B are independent. Let's now see what are dependent events so that we understand the difference between the two. And this would be really easy to understand if you go back and recall the without replacement case in the probability jar. So what was happening when the red ball was not replaced? It was very clear to you that the probability for the second draw was changing. So event A and event B are going to be dependent if the probability of the first event in a way affects the probability of the other event. So usually this case of without replacing comes under your dependent events. That's a way you can identify dependent events when you're doing some draws and you're not replacing the balls or the marbles back. But in this case also, as you saw when we solved that probability jar question on without replacement, then you still need to do the same thing. You need to just multiply the two probabilities for the two events to get the final answer. The same concept of dependent events, we will now see that the formal definition is that two events are dependent if the outcome of the first does affect the outcome of the second. So there is an effect. The probability of event A and B will get affected when it is a dependent event. And the example we've already taken, if you take a marble out of a jar, a probability jar, and you don't put it back in, that means the probability for the second draw or the second pickup will get affected. It will change, and the outcome for the second event can get affected, and that's why it is a dependent event. Take one more example on identification. You need to determine whether the event is independent or dependent, and you also need to give your reason why you say that. Very, very important. So a card is taken or selected from a deck of cards and not put back. So this not put back clearly tells you that we are not doing any sort of replacement. So this is a question on without replacement. And that is the trick that will help you to know that yes, this is going to be a dependent effect, because your probability will get affected when you draw the second card or when you're doing the second draw. So this question is on dependent events, definitely, because once you are removing the first card, you cannot put it back. You cannot select that card, same card again, whatever is coming on that card. So therefore, the probability for the second draw would be affected and the sample space is reduced by one card. You also saw that same thing when you were not replacing the marble or the ball back into the probability jar. Let's take another very similar question, example in fact on dependent events. So I'm doing a rough drawing here. This is, for example, a bag that we have, and this bag has some different color marbles. Let's highlight what are the marbles here. 3 red, 2 white and 6 blue. Now I'm just putting them with the same color, and I'm representing with the capital letter R for red, the capital letter W for white, and capital letter B for. So these are three different colored marbles which are there, and let's total first of all to get our total number of marbles. So the total number of marbles in this probability bag is 3 plus 2 plus 6, which is 11. Okay, so let's see what's happening. What is the probability of drawing in order 2 red and 1 blue marble without replacement? So I see this without replacement, and I know that, okay, this is going to be my dependent events because my probability will get affected as the marbles are not put back. So since the marbles are not replaced, it's quite clear these are dependent. And let's now do our probability. So what is the order that is specified? Very important. Let me just highlight this point for you. So the order is already mentioned. In order, you are drawing the marbles. And what are the marbles? Let's see. There are 2 red and 1 blue that you want. And this is definitely without replacement. Very important piece of information. So let's do now. So that means that in the first draw, I definitely want red. In the second row, I also again want red because I need 2 red and 1 blue in the same order. And then the third row should be blue, and I'm not putting them back. So let's go and see. And if you want, you can individually also write the probability for red and probability for blue. We're not concerned for white because it is not asked in the question. So probability for red in the first row would be definitely 3 divided by 11 because there are 3 red out of a total 11. For blue, it will be 6 out of 11. So this is all in the first draw. If you just look at the first probability. But here we need first red. So 3 by 11 would work. Now, once that red ball is removed, we know the sample space will get reduced. The total number of balls will be 10, which is left, and one red is removed, so it will be 2. So second draw, you get a red will be reduced by 2 divided by 11. That will be the probability for red in the second draw. Okay, first red is done. Now third draw, you need blue. So once you come to third draw, you've already reduced your sample space. You've already removed 2 marbles. So total will be 9. It is again reduced. And out of those 9, you have 6 options for blue to come. So in the third draw, for probability for blue, it will be 6 over 90. So I hope you have understood how the probability is getting affected. This is a very important question. I've put 2 star marks here. And if you've understood this concept of without replacement, if you've understood this concept of dependent events, then whatever numbers they change or whatever changes they are going to be doing, it will be still, you will be still cracking through the question well and getting the correct answer. So just multiply all of them in fraction form. Your answer is coming out to be 2 divided by 55, and you can convert into percentage. Definitely just multiply with 100, and this is 3.6%. Okay, so now I'm going to be taking some important textbook examples from my grade 9 textbook. And in this one, you have the same learning objective. You are learning how to identify the independent and dependent events. So let me highlight. You can read through these 3 parts. Let's do just one of them, that is A part. Remaining you can read and understand. I've given you the details answer here so that it's easy for you to understand. So independent and dependent, which event it is, that's what you need to identify first, and then again, like your previous examples, give the reason. So one coin is tossed and then a second coin is tossed. So I'm sure you will agree that because these are 2 different coins, so they're not related to each other, the probability will not at all get affected, and the outcome of the first coin in no way is changing the probability of the outcome on the second coin. So these 2 events are going to be very independent. That's very crystal clear for the example. In a similar way, you can read through part B and C, and it will be quite clear for you now based on the detailed discussion that we've done on independent and dependent events. Please check yourself. And let me know in the comment section if you still have some questions. Okay, time to test yourself to check your progress, how much you've understood. So on the screen, you see a multiple choice question. You need to identify whether it is independent or dependent and give the reason. So a marble is selected from a bag. It is not put back. Then the second marble is selected. So think about it. Is it independent? It is dependent. I want you to put it in the comment section, the reason why you feel it is that particular event. And I'm sure you all will agree that this is going to be dependent event. And I want you to put it in my comment section why you say it is dependent. And let me highlight a hint here for you. It is not put back. So this is what will tell you why it is dependent. Question to check your progress. You have to do the same thing. Identify independent or dependent event and explain your reasoning. A marble is selected from a bag. That's the first event. And then a card is selected from a deck of cards. That is the second event. You can write this as A and B. Just to make it clear, you have to tell me event A and event B, are they dependent or independent? And I'm sure you will agree that it is independent because these are two different events which are taking place. In one, a marble is drawn from a bag. In another one, there is a different set of cards from where you are drawing one card. So make sure that you have understood this concept well. If you have any queries and questions, please put it in the comment section. Okay, so let us summarize this session now, beginning from the concept of independent and dependent events. So this is the final justification, the formula that you are going to be using to find the probability of independent events, as you saw in the first example that we had taken, and the probability of event A and B happening, or the probability of event A intersection B is the product or the multiplication of the probability. So this is also called as probability multiplication rule, and remember this is applied when the events are independent. And if you're talking about with replacement or without replacement, the keyword is with replacement here. So whenever you see two events where you are drawing or you are taking out something two times and you are replacing it back, then you are very confident to say that these are independent events, and this is the formula that you will use. Just multiply their individual probabilities. That's the keyword you should remember for independent events probability formula. Let's come now to dependent event formula. Again, a hint which I can put here for you is that whenever these are dependent events, a way to identify is with the keyword without replacement. So if you are not putting a ball taken or a marble taken out of a probability jar or a probability bag, or you're drawing one card from a deck of cards and you're not putting it back, so all of those cases are without replacement, which will fall into the category of dependent event. So you have to use this formula. It is very similar to the last formula which works for independent events, and I'm sure as you've understood from the examples that we've taken previously in the session today, the only difference here is you are still multiplying, as you can see, to get the probability for dependent events. You're still multiplying the two probabilities of event A and B, but the difference is this part. Let me highlight. And what is this part? I will use a highlighter here. So this part, probability B given A or probability B over A, this is also called as, you will see that in the next session, but I will just give you the name here. This is called as conditional probability. Okay. And what is exactly this probability in similar or simple words is that when you have the without replacement case and you have the dependent events, then to find the probability for the second event, which is getting affected by the presence of the first event. So this is probability of the event B given event A has already occurred. I will write here for you. This is the probability of event B given event A, already occurred. Okay, so this is you will be able to relate to this part when you saw that initial example of without replacement of the marbles. So once one marble is taken away, the probability for the second event gets affected. So this probability is the change one, considering that the first event has already occurred. So this is the conditional probability. We'll be going into much detail in the next video on this one. And just remember that even for dependent events which have without replacement case, you still multiply the two probabilities to give your answer, or probability A and B both happening together.